Hello everyone, welcome back to Khancloudacademy. Let's start learning about Docker. So this is the new course of series I'm going to start for the Docker and very details. So first we're going to discuss about introduction part, and this is all about the theoretical part only, right? So container, this is a code written here. So let me start with the code. Containers empower developers to encapsulate innovation, packaging application with their dependencies in the realm of Docker. Each container is a vessel of agility, sailing the seas of software deployment, delivering consistency and efficiency to the source of modern development. Right. So let's start. So introduction to Docker. So Docker, what is Docker? Right. So let me read this little bit about the definition and all. So Docker is an open source project that automates the deployment of application inside software containers. These application containers are similar to lightweight virtual machines as they can be run in isolation to each other and the running host, right? Also, Docker is a tool that follows you to create, deploy, and run applications by using containers. Using Docker, you can run your software on different systems and environments, like a development environment, production environment. You can see UAT environment as well, and the software will run consistently regardless of what kind of environment it's on, right? So here you can see the two pictures, right? The containers and this VM part. So what are the difference between it? So you can see here infrastructure is both for the commons and this is hosted on hypervisor, right? So on the hypervisor, just like a VMware, you can say we have hosted a virtual machine and a multiple virtual machine. You can say app A, app B, and app C. So let's take example of app application of B. So this is a VM, and guess first you have to install a operating system, then you have to create a folder structure, and then you have to host your application. Same way, if we come to the container side, so basically you have an infrastructure, you host OS, and under the host OS, you have to install a Docker, right? You don't need this hypervisor and all, right? You don't also need to create a VM, and for this application, you are also going to maintain this operating system, but there is nothing here. So we completely reduce this layer of uh, OS layer of in the application side and a virtual machine as well. So on the Docker, you can host multiple containers, and inside the multiple containers, we can deploy a different kind of applications. So bin libraries, that is basically their folder structure and applications, right? So this is how it's work. Okay. So let me open little bit. Let me go to the simply you have to type www.docker.com, right? This is what, and when it's open like this. So this is the official website for the Docker. So Docker is also coming announcing Docker build cloud development up to 39x faster. So this is what it's all about, right? So here you can choose the plans. You have to sales contacts. Okay, so compare plans. Let's see the plans firstly, right? So Docker build cloud basically $5 per user per month. This is the and $6 per user per month monthly. Requires a Docker subscription. So now Docker is starting as a subscription based model, right? As same as the AWS, Azure, or Google Cloud they are providing, right? So same way, first you have to create your account, that is a tenant account, the base account or root account, you can say. And then you have to choose as per your subscription and you can create your team and blah, blah things. So cloud builder size, it will provide, the Docker personal. This is the for the Docker personal, at vCPU, 16 GB RAM, $50 per month, and 50 included build minutes, so 50 minutes per month, and include cache 50 total 50 GB total, right? A maximum number of parallel builds, one you can run the builds, one builds only, right? Same way we have to Docker Pro. So Docker Pro, Docker for the team, Docker for the business, Docker build cloud team. So these are all the pricing you can see here. Also, you can contact to the chat, whatever you need, you can just go and try it. So I'm not going to talk about more on this, the product side, okay, for the Docker particular. Yeah. But let's talk about this documentation part as well, right? So So Docker build cloud and local build cloud. So this is the how you can demonstration is there, and you can just check this website and you can take it. So how Docker build cloud works. So Docker build cloud shift the build workload from local machine to a remote build kit instances, resulting in remarkably faster build times even for the multi-platform images, right? So this is what is all about. So you can base, I mean, take the monthly basis. This is the very faster, guys. So this is the plan about, and let's developer for the documentation, getting started, training you can do the community, open source, preview. What the providers provides, Docker desktop, Docker Hub. Docker Hub basically a place where you can find a lot of different flavored of Linux, Windows, or kind of okay Docker Hub. So Docker Hub will help us to pull the images from the Docker Hub, and so official, and it's also scanned, security scan and everything will be there. So Docker Scout is there, Docker Build Cloud is there, and product for the roadmap. So the developer guide, the pricing guide, and the support. There's the blog, the company about. You can see, just go through these parts. So let's go to the docs. So if I click on the docs, you can see each and everything over here, right? Get a Docker. So Docker build for the cloud. Docker build cloud is a service that lets you build your container image faster, both locally and in a CI. So CI means continuous integration. Builds run on the cloud infrastructure, sorry, and in cloud infrastructure. So build run on cloud infrastructure optimally dimensioned for your workloads. No configuration is required. The service uses a remote build cache, ensuring fast builds anywhere and for all team members. So this is what how Docker build is going to work, right? So let's little bit talk about the Docker desktop. So these are the features over there, how you're going to install it in your local machine, right? So this is the everything overview is given here. So types of Docker, Docker engine, Docker Scout, Docker build, Docker extensions, So what is included in the Docker desktop? So these are the features available in your Docker desktop. For the installation procedure, we have to install on Mac. So this is what we can do. This is the system requirement. So this is saying Docker supports Docker desktop on the most recent version of Mac OS. That is the current release of Macs, that previous two releases, right? So installing the Mac OS we will do later these installation and in our practical sessions, right? So we have this is the theoretical basically we talk about the theoretical introduction of the Docker. So let's back to the slide and discuss more on this, right? So installing Docker on a Mac OS. So I'm using Mac operating system, right? So that's why I given this. But if you are going want to install in your Linux, you go with other flavor of the Linux or Windows or whatever you want. Just go through it and you just got all the commands related to this, and you can install it install it properly. So this is the requirement of the 4 GB RAM you must have, right? So you have to pass the first collect the general requirement like prerequisites for installing the Docker desktop on your local machine, right? So I written here, how you going to install Docker on the Mac operating system. So this is the prerequisite for this. Okay, to install the Docker, follow the steps. You go to the Docker for Mac, download and run the installer, continue through installer, and with default option and enter your request. So let's little bit talk about the Docker architecture. So Docker follows a client server architecture which consists of several components. So what is the component we're talking about? So Docker architecture. So from the client, and you can use these commands where you can use the Docker daemon. The Docker daemon basically hosted where the Docker is actually hosted, right? So client basically do a Docker build, a Docker pull, and Docker run, and Docker daemon basically pull the images and properly it will set up for the particular containers, right? So the registry is for the for the particular software you can put you can save this after building. You can save this as a registry. So what is written here, the Docker client communicates with the Docker daemon and the daemon manages the containers. So daemon is basically manage your running containers, right? Images, networks, and volumes. Container runs application in isolated environment, ensuring consistency and portability across different environments. So images are used to create containers, and the Docker registry serve as a repository for sharing and distributing the images, right? Now move to the next. What is Docker client? So before going through this, let's go back to our Docker. We have to check this overview, right? So Docker services. Let me. I want to show you Docker architecture, right? So let me search Docker architecture. This is the Docker docs. So always try to learn from the Docker docs only. Okay. I mean the OEM you can say directly from this. So this is the Docker architecture, which is updated. So this is the client, and this is the Docker host, or Docker daemon is here, and it's manage these images, and these images used for this particular containers, right? So you have to be clear on these points. And registry basically, uh, so what is the registry here, right? This is what we have to talk about. Docker registry. A Docker registry stores Docker images. So whatever the Docker images you want to store and reuse it, that's what we have to use. Extension, plugins, everything you can use. So this is what Docker is all about, right? Let's move to the. So let's talk about what is Docker client. So Docker client is the command line interface or API through which users interact with Docker. User issue commands to Docker client, which then communicates with the Docker daemon. What is Docker daemon? Docker daemon, or you can say the Docker, is a background process that manages Docker containers on a system. It listens from Docker API's request and manages Docker objects such as images, containers, networks, and volumes. So what is Docker images? Docker images are read-only templates that contains the instruction of creating a Docker container. Images can be built from a Docker file and then serve as the basis for running containers. So, in after the introduction, I will start creating a Docker file. We will talk about how you're going to create a Docker file step by step, and what is the prerequisites, what is the requirement of the particular writing a Docker file. So Docker itself written in a Go language. Remember this. And Docker containers are lightweight, standalone, and executable software packages that includes everything needed to run a piece of software, including the code, runtime, libraries, and system tools. So containers are instance of Docker images, right? Moving to the next, Docker registry. Docker registry is a service for storing and distributing Docker images. So whenever you build your image using the Docker file, you create an image and you can store it somewhere. Somewhere that is a Docker registry. And same way, you can say the ACR, Azure Container Registry, AWS have the container registry. So all the service provider you go with, you get it as a services, the services very easily. So the default public registry is a Docker Hub. Docker Hub is owned by, you can say, the Docker itself only. And you can also use private registries or other public registries as well. You can push and pull images to and from registries. Okay. So what is Docker Compose? So Docker Compose is a tool for defining and running multi-container Docker application. It allows us to define an entire application stack, including services, networks, and volumes in a single docker-compose.yaml file. So one more thing, guys, if you want to learn YAML and Ansible as well, I already created a one of my this playlist. You can go with on this channel and you can see this. The I just explaining the required as a DevOps engineer or the cloud operation engineer, you need to understand the YAML scripting little bit. I mean, I don't say that you are not a programmer, so it doesn't matter. Okay, you just you have to understand the writing the blocks and properly a multi-stage, single instance, and understand the blocks wise. So Docker network allows containers to communicate with each other within the same host or across different hosts. So Docker provides various network drivers for creating different types of networks, such as bridge, overlay, and host. What is Docker volume? So Docker volume provides a way to persist data generated by and used by Docker containers. So volumes can be shared among containers and are separated from the containers file system. right? So after installation of Docker images, Docker on your Mac or wherever you want, you must remember or understand the command, the basic commands, how you going to use as a using a command line interface for managing containers and related resources. So here are, I just mentioned here some of the fundamental Docker commands to anybody. If you don't know, you have to just start it. So suppose you have to show the Docker version. So Docker space version, if you type, you will get the particular Docker version. So I'm not going to show you anything on the console side, but yes, want to discuss these commands very uh, in details. So you can make a notes or just understand this command. Then whenever we do for our particular session, practical sessions, I will show you in our coming videos. So working with images. So how you going to pull an image? So we have to use command docker pull command. Docker pull command is a command, and image name, whatever the image name you want, it will directly pull from the Docker hub, right? So suppose you want to pull a Docker Ubuntu latest version you want, or you can define your version if in any particular version if you want to run it. So you can also. So I just written here Ubuntu and hyphen latest. Okay. So Docker pull Ubuntu and latest. So this is the command you have to type, and you will download you can pull the image of the Ubuntu, right? And suppose you have a multi images you already. So how you going to list the images? Docker images. If you run this command, you will get the all the list of the images. Suppose I have to remove an particular image. So we have to use Docker space RMI command and image name you have to give. So it will remove that particular. So suppose as example, Docker RMI is going to remove Ubuntu colon latest one, right? So managing containers. So run a container, Docker run image name. You have to give you it will start the running up. Suppose you build the container. So we will do on our particular sessions. So running in interactive mode, that's very important. So Docker run hyphen, you basically after that when you run the container you want to go inside it bin bash, you work as a so how you going to host your applications. So this is what command you have to use, that is called interactive mode. Docker run space hyphen it, and your image name you have to give a space slash bin slash bash. You will go to the shell command and act like a just like you're working on any Linux machine console, right? Or you can say the terminal. So list of running containers, you have to use Docker ps command, right? Next is working with images. So how you going to work with images? You have to pull an images, Docker pull image name you have to give. Same way you have to Docker pull Ubuntu. So you are going to pull it, remove an images, Docker mi, right? And same way you have to Docker RMI Ubuntu latest, right? So build an images. Okay, so both are the same thing, I think. Docker images. So build an images from the Docker file. Build hyphen t. So this command we have to use for building a Docker file. So I will guide this. So Docker hyphen build hyphen t. T is a tag name. Whatever the new name you want to give, you have to put this tag name and path to the Docker file. You must in the current directory also you have to provide that particular file path already. So where you want to save it, or you want to run it or build it. Search for Docker images. So Docker search command you have to use, and you have to give your image name, right? So managing containers. So run a container like a Docker run image name. You just give it will start running. So Docker run have an IT bin bash interactive mode. I'm repeating this again and again so you can go. So list of running container Docker PS, list of all containers including stop Docker PS hyphen A. Hyphen A basically used for which one is going to be stopped state. It will also show you. So stop a running container, you have to use Docker stop command, and you have to give your container ID. Remember this container ID, right? Not container name. Start a stopped container, Docker start, you have to give the container ID name. Remove a container, docker rm container underscore id. This is what you have to. This is very easy. Working on Docker is very easy. To remove a running container, add -f flag, docker rm -f container id you give, it will remove container completely. So execute a command in a running container, docker exe exec space -it interactive mode on your container ID, and you have to go to the bin bash. Suppose you have to clean up all stopped container unused, so network and dangling images. So docker system prone command basically used for docker system prone command used for to clean up everything, right? Okay, so next is the container logs. How are you going to check the container logs and information? So view container logs, Docker logs container ID, display container information, Docker inspect particular container ID. You have to give display system-wide information, Docker info. Managing Docker network, list Docker network ls command you have to use. Create a Docker network. How are you going to create a Docker network? Docker network create, and you have to give your network name. Connect a container to a network, Docker network, connect network name and container name. It will automatically, aligned with this particular container. So Docker volume, list Docker volume ls. Create Docker volume and command mount a volume in a container, Docker run -v, your volume name, and you have to give a container path. Where is the container path? You have to give, and it will mount automatically for the particular volume. Okay. So Docker provides a powerful command line interface. That's what we are discussing here, right? So Docker Compose. So Docker run Docker Compose, Docker -compose up. Stop Docker Compose, Docker space compose down. Okay. Docker registry. What is Docker registry? So push an image to Docker Hub or another registry. You have to use Docker push image name. Login to Docker Hub, Docker login. So these are the basic command and very useful command we have to use for operating or playing with the Docker images. Now, this very, very, very good thing is a Docker file. So everything is start from. So what is Docker file? So Docker file is a text document that contains all the commands needed to assemble a Docker image. It's like a recipe that defines the ingredient and steps to create a lightweight portable container for your application. So Docker file is a you can say the text document, and you put all the commands, and same thing you're going to build it. Whatever you build an image, you have to use a Docker file to build an image, right? This is the base work of how to create a Docker file. So first, there's a 6 point we have to keep in our mind. Choose a base images. So first we have to choose a base images. So I will guide you later on this in my coming videos, how you choose a base images. Okay. So start by selecting a base image that suits your application requirements. This could be a minimum Linux distribution or a specialized image. Set working directory. Second thing is we have to set up a working directory. Specify a working directory within the container to organize your files and applications. Right? So working directory like bin slash libraries or something like that. Copy files. Use the copy command. So we will talk about all the commands. How are you going to copy? Right? Copy file from your local machine into the container. If something you want to post, so even building the images, it will copy from your local to the container inside. Install dependencies, run commands to install dependencies and set up your application environment. So that is very important. Expose the ports. So if your application communicating over a specific port, use the expose command to make it accessible for the end users, right? Define entry point. So specify the command that should be executed when the container starts using the CMD or entry point directory. Okay. So why we use Docker? So Docker has a three qualities: the isolation, containers encapsulated your application and its dependencies, ensuring consistency across different environments. Portability: Docker images can run on any system that supports Docker, making deployment hassle-free. This is a very portability. Easily scale your application up or down by leveraging Docker's container orchestration tool. So Docker orchestration tool, what is this? That is your Docker Swarm, that is your Kubernetes, AKS, EKS, AKS, Azure Container, Azure Kubernetes Services. So this is what we talk about in our upcoming videos, right? Not today. So Docker file best practice, layer optimization. Minimize the number of layer in your Docker file to enhance build performance. Use specific tags, specify explicit version tags for the base images and dependencies to ensure consistency. Clean up, remove unnecessary files and the dependencies after installation to keep the image size minimal, right? And what about the multi-stage builds? Consider using multi-stage builds to create smaller and more secure final images. So whatever you're going to kind of customize your containers. That's why we use a Docker file, right? So next is Docker image build process. So when you run a build command, as Docker image build command, what the process we need to follow or how it's work? That's what we have to understand here. So first initialization is started. Docker reads the Docker file and initialize a new build. Layer creation. Each instruction in the Docker files creates a layer in the image, allowing for efficient caching. Intermediate containers. Temporary containers are spin up for each layer, executing the corresponding commands. So if you talk about an image manifest, Docker combines all layers into a single image manifest, creating the final image, right? So this is what it comes the later. And tagging, we have to use the image is tagged with a user defined name and version. So suppose you are creating a multiple images and you will need a particular environment. So you can also you have to control the version, the first version, second version, or something. You added a new layer creation, right? So or maybe you added some few more commands. So accordingly you can tag it. Now we have to talk about Docker image type. That's very important. We have to first understand the theory part. So what is base image? Base images are minimalistic and serve as the starting point of creating other images. Examples include images based on Alpine Linux or other lightweight distribution. They provide only essential component and are often used to reduce image size. Okay. Official images. So Docker maintains a set of official images for popular software such as databases like MySQL, PostgreSQL, or web servers like Nginx and Apache, and programming languages like Python and Node.js. So these images are well maintained, regularly updated, and generally considered reliable. So let me show you. If you go to this is the Docker, and I'm going to, I will show you, I want to show you the Docker Hub basically. Mm, 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 mm. That we have to type Docker Hub. Okay. So you must aware of this website as well. So you have to first you have to create an account or sign up with your account, right? And you can search over here, suppose Nginx. So it will give me all the Nginx images. You see this? So it will already be Docker official images. That's what I want to show you. 1 billion plus download, 10K plus star. So this is the command for the Docker image Nginx. And tags as well, the tagging somewhere it is tags like get Linux 36 AMD. So as per your requirement, you can download it. Even if I type here MySQL, so we'll get it. MySQL. This is verified. So MySQL is a wide used open source relational database management system RDBMS. You can download directly from here, right? Everything is clear here. MySQL, what is this? You can read about it, how it's going to work, Docker on it, how you going to run these commands. So most familiar with these things. So in upcoming videos, we will do some practical over here and we use these images to build our new images, access it, destroy it, right? Okay, so let's move to the custom images. Custom images are created by users to package their own application or services that typically start with the base image and include additional component configuration or dependency specific to the user. So whenever you're using a Docker images, Docker file, that is you actually doing a custom imaging, right? Builder images are designed to facilitate the build process with the containers. They include necessary build tools like compilers, dependencies to compile a package and application before the final runtime images is created. So if I write here build, let's see what is showing. OpenJDK, CentOS, the official build for the CentOS, or maybe more. So you cannot say that maybe in that particular build you got more software or servers installed, right? So operating system Linux and Windows both are images are available for this, right? And builder images this is done. Data volume images, so data volume images are used to share and persist data between containers can mount volume from these images, allowing data to be shared and preserved even if the original container is removed, right? More command if you talk about sorry, Docker image type. So multi-stage images help optimize the size of the final production images. They involve multiple stages with the intermediate images used for the compiling or building the application and a final smaller image for runtime. So microservices images encapsulate individual microservices in a containerized environment. Each images represent a specific microservices, making it easier to scale and deploy modular component of an application. Official repositories images, Docker Hub and other containers registers host official repositories with curated images. These repositories may include a variety of images such as developer tools, utilities, or specific software stack. Scratch images. The Scratch images is special minimalistic images with no underlying operating system. It is often used for creating completely custom and minimal container, especially for static binaries. Windows images is also available. So for Windows lover, they can download and start working on the Windows side as well. So Docker support Windows containers and images for Windows based application are available. Like you have to run any .NET kind of application. So you can use these Windows images and you can run your application on the Windows images. Windows Server Cores and Nano Server are common base images for the Windows containers. So these are also available. Okay. So what is lightweight Docker? This is the very common question asked in the interview. What is lightweight Docker? So a lightweight Docker image typically. So I written everything, guys. Okay, so you don't need too much worry about it. Every notes you can get it here, right? You just note it is or learn it and go and crack the interview. So a lightweight Docker image typically refer to an image that is designed to be a small in size, containing only the essential components required to run a specific application. The goal is to minimize the image footprint, making it faster to download, deploy, and share. This is the main purpose of it. Okay. So reducing the image size is important for various reasons, including faster deployment times, improved resource efficiency, and enhanced security. Let's little bit talk about the characteristic of lightweight Docker images. The first thing is the base image. So base image, if you use, these are lightweight images often start with the minimalistic base image such as Alpine Linux. These lightweight Linux distributions provides a small and efficient foundation for building containers, single purpose images. Images are tailored or to serve a base specific purpose for or application containing only the necessary dependencies and component required for that particular use case. So this is what you're going to explain if ever you get asked in any interview, what is the lightweight Docker? Optimized layer. The Docker images layer are optimized to minimize redundancy and maximize reusability. This is achieved by grouping related commands together in the Docker file to create efficient layer during the build process. So dynamic linking lightweight images often leverages dynamic linking to shared libraries, allowing multiple candidates to share the same libraries and reduce the redundancy. Multi-stage builds. The use of multi-stage builds is common for creating lightweight images that involves using multiple Docker file stages to build and compile the application in one stage and then copy only the necessary artifacts into a smaller runtime images. What is smaller runtime? The lightweight images are smaller and more efficient runtime, such as BusyBox or minimalistic version of programming language runtime. Alpine is a popular choice for creating lightweight Docker images due to its small size and minimalistic design. It provides a functional Linux environment with a very small footprint. right? So this is what is all about the lightweight Docker. So I included, most of the theory part for the Docker. Beyond this, you will not find anything else. Okay. Benefit of lightweight Docker images must have to discuss. So faster deployment, improve resource efficiency, reduce attack surface, easier distribution. So faster deployment means smaller images lead to faster download times, reducing the time it takes to deploy containers, right? Improved resource efficiency, container based on lightweight images consume fewer resources, both disk space and memory, making them more efficient. Reduce attack surface, smaller image typically means fewer installed component, reducing the potential at programmatically attack surface and improving security. Lightweight images are easier and quicker to distribute, making them suitable for environment with limited bandwidth. Okay, so next topic or in our upcoming videos, we will going to discuss about building the images, right? We'll discuss about the building images, and we will start with, how you're going to use your Docker file, create a imaging. And we will, whatever the command I showed in this video, I will use each and everything and whenever we do the particular session. So next time when I come, I must have in my MAC address, Docker must be installed, right? So thank you very much, guys. Please like and subscribe this channel, and let's see you on my next videos. Thanks for your time. Have a nice day.